Hello mathematicians, just probably more about notation than anything else this section. It's about the notation dydx. We've mentioned it in passing, but it's just an alternative notation. And it's an alternative notation for the derivative based on this symbol, delta. And delta indicates a small difference. So previously we talked about points on the curve y equals f of x as being x, y, or x, f of x, and q being x plus h, and the y value being f of x plus h. Now we're just going to literally call them x and y, and x plus a little bit and y plus a little bit. So the q is a point not far from p, I guess, is the upshot. So we can find the slope of the second, and that's change in the y values over the change in the x values, y2 minus y1. So that's actually, if you go through and plug into the formula, delta y over delta x. So the slope of the tangent, which we know is the limiting case of the second, is the limit as that little difference heads towards zero of the slope of the second, and that gives us the slope of the tangent, dy dx. Now, as far as applying rules go, there's absolutely no difference. So I'm just going to do some of these examples, talk them through, particularly with regard to gradient and tangent, and see how we go. So for our first question here, I might just do d and f. And our idea here is that if this is what y is, then dy dx we find in exactly the same fashion as we did up above, using our rule. So when we differentiate this term, the 3 will come down. 3 times the third is 1. Subtract 1 from the power, and we've got x squared. Our next term will become a half x, and our last term will become 1. And for f, dy dx simply equals 0. Now, our next question, find the gradient and angle of inclination of this tangent at this point. So if we first of all take y equals x plus 1 squared. Now later on we will have a rule which will let us do this in one hit, but at the moment all we can deal with is separate terms. So remember our expansion of the square, square of the first, twice the product, and square of the second. So dy dx, the expression for the gradient anywhere, will be 2x plus 2. And we want for this curve to be particularly interested in the point where x equals 0. So that means that we want dy dx when x equals 0, which is of course the gradient. And that will be 2 times 0 plus 2, so the gradient is 2. So we've found the gradient. Now to get the angle of inclination of the tangent, then we know that m equals tan of the angle of inclination. So 2 equals tan of alpha. So alpha is the angle whose tan is 2. We go to the calculator and evaluate that, and we see that the angle of inclination is 63.43 degrees. Or if we press the degrees, minutes, seconds button, 63 degrees, 26 minutes and 5 seconds. So to the nearest minute, 63.26. So that's going to equal 63 degrees, 26 minutes. Okay. Now our next question is perhaps more like the extension 1 questions you'll face. So, and I haven't got a lot of space here, so I'm going to squeeze things up a little bit. So part A says find the equation of the tangent. So as above, the process where we found the slope of the tangent and we've got a point that it passes through, the extra step is that we have to be able to substitute into y minus y1 equals m outside of x minus x1 if we're going to get the equation of a straight line. So this is a key equation. So for part A, first step is find dy dx. So that's going to be 3x squared. So that's going to give us m is dydx when x equals 1, so that will be 3. And we've got the point, so if we plug straight into our equation, we've got y minus y1 equals m outside of x minus x1. And if we rearrange that into whichever form we like, well, we've got to have a sketch, so I might put it into gradient intercept form. So that will be, and again, apologise for the setting out, y equals 3x minus 3 and then plus 1, so 3x minus 2 as our equation for the tangent. Now to get the equation of the normal, the gradient of the normal is minus 1 over 3. Therefore, y minus y1 will equal minus 1 over 3 x minus x1. If we multiply it through by 3, well actually I won't do that because I still want to make y the subject. So if I make it y equals minus a third x, and then if I multiply this out, that would give me plus a third plus 1, so plus 4 on 3. Part C, find the coordinates of the y-intercepts t and n of the tangent and the normal. And then part D, sketch the situation and find the area of the triangle. So I'm going to start doing both of those together. So if we look at our sketch, I'm just trying to make it a little bit tidier, then y equals x cubed will look like that. And our tangent is going to intersect the axis at minus 2 down here. So from the point 1, 1, so there's my point 1, 1. My tangent, if you have a good imagination, goes like that. So this was the where y is minus 2 and this was t for tangent. This point just here. And my normal is sitting like this, and that point there, n for normal, and it was at plus 4/3 as we can see. And I want the area of triangle ANT, so this point here at 1, 1 was A. So I want the area of this triangle in here. I'll just colour it a little. So this triangle in here. So for that triangle, area of a triangle, area of the base, area of triangle is of course half base times height. So base is from 2 up to 4/3, so that's 3 1/3, which is 10/3. I want a half of that. And the height is that distance there, which is a horizontal distance of 1. So the area of the whole triangle then it's going to be 5/3 of a square unit. Okay, so try 7D.